the first topic of our syllabus. The name of that topic is that rotational dynamic. The name of the topic is that rotational dynamic. Okay. In this rotational dynamic, we have to discuss the different topics based on circular motions and rotational motions. Now, today we discuss already the definitions of displacement, velocity, and different types of displacements and velocity. So there are two types of displacement: linear displacement and angular displacement. Linear velocity and angular velocity. Linear displacement and angular displacement. Okay. Now today we have to discuss the relation between linear velocity v and angular velocity v. Linear velocity v and angular velocity v. Angular velocity. Okay. This expression we have to discuss today. For that, we have to consider the uniform circular motion. For that, consider a particle of mass m performing uniform circular motion. Let O is the center. A is the initial position and B is the final position, and theta is the angle between them, and particle is in a anti-clockwise direction. Now, according to the definition of linear velocity and angular velocity, what is linear velocity? Linear velocity is nothing but rate of change of linear velocity. Linear velocity is nothing but rate of change of linear displacement with respect to time. So for that, consider r is the radius of the circle and delta s is the change in displacement with respect to time. Then according to definition, what is the definition? Linear velocity v is equal to limit delta t tends to 0 delta s upon delta t. But here delta s is equal to r delta theta. Where delta theta is the change in displacement, r is the radius, and delta s is the change in angular displacement, and delta s is the change in linear displacement, small displacement. The displacement is in a varying condition, varying position. Okay, now substitute in this equation. So v is equal to limit delta t tends to 0, s is equal to r delta theta, that is r delta theta upon delta t. Now r limit delta t tends to 0 delta theta upon delta t. R is nothing but radius, so taken outside of the limit. So r limit delta t tends to 0 delta theta upon delta t. Then what is limit delta t tends to 0 delta theta upon delta t? Change in angular displacement with respect to time. That is angular velocity. R is equal to v into omega. V is equal to r into omega, or v is equal to r omega. So this is required relation. Between, कशातला relation आहे हा? Relation between linear velocity and angular velocity. Linear velocity and angular velocity. Okay, so this is the required relation between linear velocity and angular velocity. So it is the required relation. Okay sir, check करूंगा.